Right. Can you hear me? Everyone, can you hear me? In the group, let's chat. Okay, in the group, let's chat. Uh, okay, there's a poll in the group. There's a poll in the group. I just put it now. Just vote. Can you hear me or not? Check one. Check two. Can you hear me? Can you hear me? The YouTube chat is disabled. Huh? You should chat in the group. Your doubts and everything should be put in the group. Huh? Okay. Right. How many people now joined? Let's see. Still more to come. Let's wait a few minutes. The board is little bit crooked now. Wait a minute. Right. All right. Right now, shall we start? Shall we start now? Okay. I think the organic seminar people are here. Organic seminar people are here now. Okay. Now, unlike the last class, the Zoom chat is not there. Okay. The Zoom chat is not there. You should chat in the WhatsApp group. Huh? You should chat in the WhatsApp group. So, okay. So today we are going to discuss. What are we going to discuss? We finished what? We finished reactions of organic. That was just 3 days of pure theory, right? So 6 hours, 5 hours. Last one was just 3 hours, 3.5 hours. So we finished reactions. It was a hard time finishing them, right? So it was big sessions. Okay. Alcohol was the biggest one, and we had many experiences from that, right? So this one we finished, right? We finished this one. Then today we are going to do identify. First we are going to do short notes. Okay, there are 2 short notes, small short notes. What I call them ultra power short notes, right? Ultra power short notes. Okay. Then next we are doing identification. Right? We are doing identification in organic. Okay, identification not in inorganic. Those things are combined here. It's only organic. Okay, it's only what? organic. Right. Then next we have in our tute, what do we have? We have carbocation stability. We have carbocation stability. And most importantly, we have acidity variation. Acidity variation, then basicity variation. Right? Acidity variation, basicity variation. Then after that, right. That's all I think. Identifications, acidity, basicity, carbocation stability, and finally boiling point. Boiling point variation. Right. Now, first I'm going into the most important one. Okay, we need to finish the most important ones first. What are we going to finish? The acidity variation. Now, take a piece of paper and write acidity variation of organic compounds. What? Acidity variation of organic compounds. Right. Acidity variation of organic compounds. Okay, now tell me, what do you like from acids or bases you like? I'll ask in the group. Okay, what do you like? Do you like acids or bases more? What do you like more? Acids or bases? What is your answer? Acids or bases? Now boys will like acids, I know that. Most probably. Okay, answer in the group. What do you like? Acids or bases? Quick, everyone, come on. Okay, acids. Yeah. Why do we all like acids? Huh? So everyone vote. Huh? I need you to be active. Be active in the class. Be active in the class. Although you haven't finished organic, maybe you didn't do class. So I have the recordings. Huh? The reactions in organic we did, and there are 3 recordings. I have the recordings, so you can just pay and get them. I'll tell in the group later. So that's another thing. Today we are doing a free session and open link, so everyone can join. So most of the people said acids are better. Why? Now when you are thinking acids and bases, what do you think? Acids are like the big guys. Okay, acids are like, okay, it's very burning sensation, right? It's very burning and it's very tough and rough. The acids are more like in a higher place in your mind than bases. But actually, these acids are very cruel. What do you mean by cruel? You'll understand that later, because bases are the donating guys. Who? They are the donating guys. What do? They steal. Right? They are the bad people and they are the good people. So actually, acids are the bad people. Why are acids the bad people? They are trying to steal. What do they steal? Electrons. Bases, what do? They try to give electrons. So actually, what does acids do? What do acids do? Acids will chase H plus out of the compound. What do? They will chase the H plus out of the compound. And bases, what do? They will accept the H plus. What do? They will accept. कोई हरी carrying H plus connect electrons, right? They are going to give electrons to roaming H plus around. So what do? They are donating electrons. They are saying like, H plus, right? What is an H plus? H plus key and a proton, right? H plus is a proton. Okay, now this guy is roaming around, no one to bond. So what happens is this base will say, okay, come and bind with me. I will give you the electrons and I will give you a place to stay. So the bases are donating the electrons such that the H plus will come and bind to it. Okay. Now what do acids do? Acids will be like, okay, I have H plus and I am pulling his electrons and chasing him away. That's what happens. Okay. Acids, what will do? Acid will chase the H plus. Chase the H plus out of the compound. You will understand this better once I write the variation. Right. Now, there is a basic variation. What is the basic variation? Okay. First, you need to understand the acidity variation starts from alkynes. What? The acidity variation starts from alkyne. What do you mean by that? Actually, these alkanes CH3, CH2, CH3 and CH3, CH double bond CH2 and finally CH3, CH not CH, C triple bond CH. Okay. Now, when you are considering the acidity variation of these compounds, this guy is very innocent. What do you mean by innocent? They do not have acidic hydrogen. There is a point why these two compounds are neutral and this one is not neutral and this one is going to be acidic. Now, why it is acidic? This hydrogen can be removed. How? You learned, I think you're in classes, you're doing alkynes, alkane. Maybe you have done this in classes. So what happens is this hydrogen is going to react with a metal-like compound and it's going to replace this hydrogen with CNA and it's going to release this H plus outwards. Why does it remove the H plus and why do these compounds does not do it? Let's see why. Okay, let's see why. Before that, I'll write the variation. Right? So what did I tell now? So what did I tell from the beginning? From the beginning, I explained what are acids, what are bases. What do acids do? They will liberate H plus. So what do bases do? They will gain H plus. Now you might have learned that they are liberating OH minus. Bases are liberating OH minus, and acids are gaining H plus. Right? Sorry, acids are liberating H plus and bases are liberating OH minus. So like there are three principles in pH. You will learn this. I know most of you don't know it, so most of you will not know it. Right? There is Arrhenius theory, and there is Lorig-Donnelley theory, and there is a Lorig-Donnelley, and there is another one. Okay, there are three theories given. So from those three theories, one theory explains about this H plus thing. Okay, about this H plus thing. So you know, acids are going to liberate H plus and bases are going to gain H plus. That's all you need to know. Okay, in this acidity variation, only you need to know acids are liberating H plus and bases are gaining H plus. That's it. Right? That's it. Now I'm going to write the variation. First, what you have? I'm taking a simple alkyne CH3, C triple bond carbon hydrogen. Okay. Just know this variation. No? Just know this variation. I'll write it a bit this side now. CH3, C triple bond hydrogen. Right. After that, we are going to have aldehydes, ketones. What do you have? Aldehydes. I'll put a slash and I'll put CH3 because aldehydes and ketones are both same acidity. Okay, they are both same acidity. So they do not have a difference. After that, I'm going to put an alcohol CH3, CH2, OH, some alcohol like this I'll put. Then after that, what do we have? After that, we are going to have a surprise compound. I'll tell that surprise compound later. Then after that also, we have a surprise compound. Okay. Then finally, not finally. No, the surprise compound comes here actually. It's going to be phenol. Yep, no, correct. Here comes the surprise compound number 2. Then here comes phenol. Okay, now the benzene you can draw this anyway. You can draw it straight. I can draw this like this also. So OH. Right, this is phenol. Then the most acidic, I'm going to go into CH3, C double bond oxygen, OH. What's this? Carboxylic acid. Okay. Now these two are surprise. Okay, these two are surprise. This one and this one. You don't know what are they. Now what is this? The most acidic, carboxylic acid. but it is not the most acidic. And the final surprise compound comes later. That one I am telling at the end. Okay, for now you need to know this variation 1, 2, 3, 4, 5. Okay, these 4 you need to know. So these are like, they are like surprises. Okay, you will be surprised once you hear them. Okay, you will be surprised once you hear them, and this one also big surprise. Okay, this one also big surprise. So what you have? You have alkyne, aldehyde, ketone. Then more acidic is alcohol, and more acidic is phenol, and after that carboxylic acid. Right. Now what are these surprise compounds? Now I am going to tell you something very disturbing to your mind. Okay, something very disturbing to your mind. You have your water bottle, right? You have your water bottle, and there is water inside it. Maybe you don't have a water bottle. Maybe you have a glass of water on your table. Okay, whatever. This one has more acidity than this one, and this one, and it's going to move into this place. Wow, that's like a wow, right? So don't be scared. Huh? Now your water, you will learn this in pH actually. You will learn this in pH. Your water has H2O, right? So what does it happen? H2O will dissociate. H2O will dissociate into H plus and OH minus, right? H plus and OH minus, the H2O will dissociate. So this H plus is there, right? So this H plus is a very tiny amount. How much? 1 10 to the power minus 7 actually. 1 10 to the power minus 7 moles per cubic decimeter. So this much amount of small H plus is making H2O go into this place. So what can you tell about these things? They are less acidic than even water. Okay, you can drink water. You are okay with drinking water, right? So these guys are very less acidic than even water. So how can alkanes be even acidic? Okay, how can alkanes even be acidic? So the variation we want starts from this alkyne because of this hydrogen. There is something to talk about. Here. This hydrogen is going to be acidic, right? This hydrogen is going to be acidic. Then these guys are obviously acidic more than them. Then comes water. And there is another compound here. So this compound, why does it come here, is not explained in the syllabus, but you need to know it. This is a methanol. This is methanol. CH3OH is methanol. Now you might think this is alcohol and this is also alcohol, but this is a special alcohol and this is just other alcohols. Okay, these are other alcohols: methanol, butanol, pentanol, hexanol, whatever you can take alcohols. Then here it's going to be CH3OH. So it's only methanol. Methanol is going to be more acidic than water, and water is going to be more acidic than these things. Alright. Right. Now you have this phenol after that. Okay. Now this is the place where the real acidity starts. This is the place where real acidity. What do you mean real acidity? If phenol gets into your skin, it's going to like little bit, what happens is like it's going to make a like it's going to be burning sensation, and phenol is acidic to skin. So it's going to be dangerous after this. Not much, okay, not much. We actually did practicals with phenol in school. So like some people did the same practical 20 times because there was like what do you call, workshop like thing. So other schools came and we did the practicals. The same practicals we had to do like 20 to 30 times. Luckily I got inorganic. The organic side I didn't went. I did some practicals, that's another story, right? We just shifted things and did. So I didn't do much of this practical, only once or twice I did this practical. So that one also we should like compare the acidity of this one and nitrophenol. I'll go into nitrophenol later, okay? For now, just write this down. Now the people who came to the organic seminar will know the procedure. I will give this and then you should write it down and put in the group. Done, okay? So you should put in the group. Done in the Rankers Club 2024. Put done, okay? Everyone will see it. No matter it's like you You're just a person. Don't be shy. Put done in the group, 1024 group. I won't put polls, right? Okay. Start from here, go up to here, and then come back. That's how you should go. Right. Sharvis and everyone, okay? I need your support now. Zuha, Sharvis, the people who came to the opening seminar. Mokshi. Right. Am I covering the board? Others, come on. In the group. Others, have you finished writing? Have you finished writing, others? Everyone talk, huh? Everyone should talk. Come on, everyone should talk. Right. Good. Perfect. Well done. Right. Then, after that, we are going to move into this expanding R group thing. So, I'm going to take one compound out of this to explain you that. Okay, I'm going to take one compound of this to explain you that thing. Right. I'm going to take what? Alcohols. So, this theory applies to every compound. Huh? This theory applies to every compound when you're comparing acidity and basicity variations, right? So I'm going to take two compounds. So you take CH3OH, and next one I'm going to take CH3CH2OH. Then I'm going to take another compound CH3CH2CH2OH. So where I'm going? Where am I going actually? I'm going to see how the acidity varies with this R group. With this R group, what happens to the acidity? When the R group increases, what happens to acidity, and what is the most acidic and what is the least acidic? We are going to look at the theory behind this. Okay. Then, නිකන් ඉන්න compound එකකට H+ දෙන්න පිස්සුවක් නැහැ. මොකක්ද කිව්වේ? What did I tell? A compound which is stable. A compound which is stable. For example, CH3, CH2, CH3. Move නිකන් H+ දෙන්න ඕනේ කමක් නැහැ. Like he doesn't want to give H+ just. He should have problem with him to liberate H+, right? So that's the problem. There's still a problem here. Okay, there is no problem for this guy. So he's not acidic. He doesn't release H+. Compounds are not mad enough to just release H+. Okay, they are like not maniacs, okay, just to release H+. But what do? There's a problem here. What's the problem happening? There's an issue here. This oxygen, you know this oxygen, right? This oxygen is going to be the world's second most electronegative atom. Now, how do you remember the electronegativity? Now, what did I tell you in the seminar? I sent you FONCLS. These two things you just need to know it. No need to know it much. So it's going to be like phone calls. Okay? The most acidic compound is not most acidic compound. Most acidic element is going to be fluorine, and after that oxygen, after that nitrogen, After that, chlorine, and finally sulfur. Then other things come after that. Okay, so who is the world's second most electronegative atom? It's going to be oxygen. Then this oxygen is here. Now what does he do? What does this oxygen do? This oxygen is going to pull electrons. Okay, this oxygen, what does he do? He is going to pull electrons. So if the most electronegative atom, what does he do is he will pull electrons. And the CH3 group and CH3 CH2 group, CH3 CH2 CH2 groups, what do? They will donate electrons. What? They will donate electrons. If someone want electrons, what do? Is they give electrons. They are like pushing groups. So when the length or the size of the carbon chain increases, what happens is the acidity is going to, not acidity, the amount of pushing of electrons is going to increase. So this is like one arrow I'm going to put. So this is two arrows. This is going to be bigger one, three arrows. What did I tell? This one arrow, two arrows, three arrows. So this carbon chain is going to push more electrons than these two ones. Okay. So make a interesting. Okay, this is like very logical. This acidity variation is very logical. So like you should listen properly and you should like take it as a story about what's happening here. Okay. Now what happens is there is a problem I said to you. This oxygen is going to take electrons, right? It is the most electronegative atom. So what does it do? It takes electrons. So I said to you like it's a stealing thing. So what happens is this oxygen needs electrons. However, it needs electrons. So what does he do? He will pull electrons from this innocent hydrogen. And this hydrogen is going to leave. This hydrogen is going to leave as H+. Okay, that's the sad story of this. So this oxygen will take all of its electrons and he will chase the H+. Okay, now here it is less. What do you mean by less? Now he is providing electrons more than him, right? So he has a little bit of electrons. So like it is less, not much, just little bit less. Okay, he will also have to go, but he will provide more electrons, more and more electrons to this oxygen. So like he's very satisfied now. Okay, it's okay if you go or not. I don't care. If you want, you go. Likewise, if you want, you go. I don't care much. That's what's happening. So what happens is, පෙරේතකම අඩු වෙනවා. මොකද කියන්නේ පෙරේතකම. දැන් ඔක්සිජන් ඉලෙක්ට්‍රෝන වලට පෙරේතයි නම් ඔක්සිජන් වලට ඉලෙක්ට්‍රෝන්ස් දෙන්න කවුරු හරි ඉන්නවා නම් මේ කට්ටිය ඉලෙක්ට්‍රෝන්ස් දෙනවා ඔක්සිජන්ට. හරි? දෙනවා නම් එයාට ඕනි ප්‍රමාණය අඩු වෙනවා. Now think you want chocolate. Okay? Now think you want chocolate. And let's say like somebody is giving you chocolate. So your neediness is going to reduce, right? So that's what this oxygen also does. When this oxygen needs electrons, if he's providing electrons, he's satisfied. So this hydrogen doesn't have to leave much. So what happens to acidity? Now acidity means ability to liberate H+. So move ගහලා පන්නනවා. අයියේ මෙතනින් electrons වැඩි හම්බෙන්නේ නැති හින්දා move ගහලා පන්නන්නේ යන්න කියලා. It's like here you must go. This what this oxygen will tell you this hydrogen. Okay, you must go. You should go. You can go. Okay, that's what's happening. So this oxygen is telling this. This oxygen only telling this. You must go. Must means you definitely should go. Then you should go means like less than. Less powerful, okay, less powerful. You should go. Then you can go. If you want, you can go. I don't care. If you want, you can go. So what happens to acidity? Acidity is going to decrease downwards. Acidity decrease downwards. Okay? තේරුණානේ? සීන් එක තේරුණානේ? අවුලක් නැහැ. ලොකු ඒසයක් නැහැ. මෙතන තේරෙනවනේ මොකක්ද කියන්නේ කියලා. ඔක්සිජන් ප්‍රොබ්ලම් එකක් තියෙනවා මේ කම්පවුන්ඩ් එකට. ප්‍රොබ්ලම් එකක් නැතුව H+ ලිබරේට් කරන්නේ නැහැ කවුරුත්. හරි? problem එකක් තියෙනවා. problem එකට solution එකක් තමයි හොයන්නේ. මොකද්ද solution එක? oxygen ට electron ඕනේ. oxygen ට electron මදි හින්දා මෝ එලවන්නේ. හරි? Oxygen needs electrons, so if it doesn't get electrons, it's going to chase away this hydrogen. That's it. Okay. So here, this electron providing mechanism is less, and here little bit more, and finally here it's more than everything. Okay. The electron providing this pushing thing is greater here. So what happens to acidity? Acidity is going to decrease. Thernani, did you understand? Did you guys understand? Did you guys understand? Did you guys understand this thing? This alcohol thing? Okay. Now write this down. Write this down. Huh? Write this down. Write this down. Write this down and tell done. Okay. Now there are 10 members in the meeting. Others should talk. Huh? Everyone should talk here. Everyone should support. Okay. Everyone should talk and everyone should support. Now I'm going to give you 3 compounds and I'm just asking you to build up something, build up your own theory from this thing and say me who is going to be more acidic. Huh? Now I'm going to ask you something. Okay, I'm going to ask you something and I need you to answer which one is more acidic here. CH3, CHCl, CH2, OH. I'll say this compound A, this compound A, the above one is compound A, and then compound B, CH3, CH2, CH2OH. So who's going to be more acidic in the group? Okay, build your own theory. Who is going to be more acidic? In the poll, who is going to be more acidic? Online people, talk. Talk means chat, not chat. Vote. A or B? Come on. Just put something Anyone can't see your votes. Who voted you? Anyone can't see it. I think so. Anonymous voting, I think. Okay. Only I can see who voted. A or B is going to be more acidic. So think like who is going to push more electrons. So who's going to have a problem here? More problem who's going to have? Just build up your own theory and tell me. A or B? Come on. A or B? Okay, someone says B in the private chat. Okay, A is going to be more acidic. Okay. A is going to be more acidic. Some people B. Okay. Now listen. Now listen. Now listen. Now listen. Now listen. Now what happens here? This group is going to push electrons as I told you. So this oxygen is very stingy for what? For electrons. Here what happens? This one is pushing electrons to oxygen. And meanwhile doing that there is someone else. වෙන මොකෙද්ද කියලා මෙතන ඉන්නවා. හරි? ක්ලෝරින් උත් simple නෑ වූ ලෝකේ 4 වෙනියට වැඩිම electronegativity තියෙනවා. ඒ කියන්නේ he is having the world's 4th largest electronegativity and he is coming and attaching here. So what will happen? They should donate him also. Now chlorine is like, okay, I also want electron. I am the 4th most electronegative atom. So I also want electrons. So you should give me also electrons. So this CH3CH2 group will think, okay, I will give oxygen a little and chlorine also very little. So what happens is, this oxygen will receive less electrons than this oxygen relatively. So, who is going to be more acidic? Who is going to be more angry now? Okay? Who is going to be more angry? He is going to be more angry and he is having the more positivity. So, what happens is, he is going to chase this hydrogen away more than him. More than him, he is going to chase him away. So, who is more acidic here? A is going to be more acidic than B. Okay, A is going to be more acidic than B. If you want, write this one in your own words. I'm not going to give a note. Okay, I'm not going to give a note. You know why? Because like these things are asked in MCQs. Okay, these things are asked in MCQs, but there are some questions which they ask in the they ask in the essay question and which are given in the resource book. They are given in the resource book. Now these things are not given in the resource book as definition. Okay, this is the theory. This CH3CH2 group is pushing electrons and this chlorine is attached. So chlorine is also pulling electrons. So the net electron density in the oxygen is less than this compound. So hydrogen is easily removed than here. So this one is more acidic than this B compound. Okay. So MCQs are the target here. Okay, MCQs are the target here. So I'm like telling you more convenient way to remember this theory. I'm like telling you more convenient way to remember this theory. Right? You wrote this and you write this and you should write this also. You must go, you should go, and finally you can go. Okay, done. Right. Okay, let's move on now. Now next is, I will go into one by one compound. Okay, now I wrote a variation. First I wrote alkyne, then aldehyde ketone, then I wrote what? Then I wrote what? I wrote alcohol, then I wrote water, then I wrote methanol, then phenol, and then carboxylic acid. Now I will move into alkyne. Write the topic alkyne. Write the topic alkyne. Okay. Write the topic alkyne. Alkyne, na? Right. Alkynes. Why are they more acidic? Why are these people more acidic than these compounds? Okay. Alkene and alkyne, let's see. Okay, the reason is in our syllabus what they have said is, you know, electronegativity. Now you should know this. 2024 people know this. Even 2025 people know this. Okay. Second lesson bonding. Electronegativity variation. You will learn electronegativity variation, periodic variation. Unit number 1. You will learn periodic variation. So you will first learn the periodic table, who invented those things. Then you will learn the periodic table variations. Electronegativity variation, you will learn the Pauling scale and stuff. In bonding only you will learn, okay, this one. Bonding last part. You will learn this S character. So this carbon's hybridization, I can write it as sp. P. How do you do that? This is how you do it. 1, 2, 3. 3 minus 1, 2. Sp2. 1, 2. 2 minus 1, 1. So Sp1. Sp1 means Sp, right? So what happens is there is a 50% S character here. 50% S character. This is like bonding or bonding knowledge. I can't teach you that here. Okay, this is organic. You need to know this. So S character here is like what do you call? 33%. Why 33%? There are 1, 2, 3. This is 1S. There is 2P. So this is like 33%. 33, 33, 33, 99%. So like it's 33.33333%. Okay. So here 50% S character. Here 33% S character. Right. Now what happens is when the S character increases, electronegativity increases, and this carbon is going to pull electrons from this hydrogen. And this hydrogen is getting, this compound is getting a slight acidity. What? Very slight acidity. And this hydrogen is going to get removed. This hydrogen is going to get removed. Make a Sp2 is not enough to create any acidity. Okay, Sp2 is not enough to create any acidity. If you want, write this down. Okay, write these two compounds and write this note I am telling you. Okay, for writing these two compounds, I will give you 3 seconds. Not 3 seconds, 5 seconds. Okay, 5, 4, 3, 2, 1, 0. Okay, now write this. When S character increases, the electronegativity increases. When S character increases, the electronegativity increases. Right? When S character increases, the electronegativity increases. When electronegativity increases, right, correctly. When electronegativity increases, it pulls electrons from hydrogen. What did I say? When electronegativity increases, it pulls electrons from hydrogen and chases it away. Don't write this in exam, okay? Don't write this in exam. It's for your understanding. Okay? From hydrogen and chase it away. Don't try chase it away in exam. To liberate H plus, you can write in exam like that. Okay? Right. Now before this I said you that this carbon chain increasing is creating more acidity. Likewise here also, if the carbon chain is larger, the acidity is going to reduce. Why? This R group is going to push electrons towards this carbon and it's going to reduce its electronegativity. It's stinginess for electrons. It's going to reduce. Okay. So that theory applies everywhere. The R group, the size and the length increases, the electron pushing increases, so acidity is going to reduce because the angriness of this oxygen or carbon is going to reduce. Right? That's it. Then after that, there is another explanation given. What is this explanation? You can explain the acidity of this R group thing this way also. You can say CH3CH2OH is there, CH3CH2OH. Now it's going to dissociate into CH3. This H plus liberated. Okay, H plus liberated means CH3CH2O minus and H plus. So here what you have CH3CH2OH. So there is 3 carbons, so R group is larger here. So it's going to dissociate CH3CH2O minus plus H plus. So this explanation is based on the resource book, and this is more logical. I mean, this is what you should write in exam. The other one you can just build it in your own words and just write it. Okay, you can just write it, but use good words. Okay, don't write chase it away. Angriness increases, electronegativity. Don't write them. Okay, I just say it for you to understand. Okay, don't write the exam. This oxygen is pulling electrons from this poor hydrogen, and don't write like that. Okay. Now here what happens? We are going to look at stability. We are going to look at stability. Now this oxygen is negative, right? Anion. What are they called? Anions. Anions. Anions are negative charges. Anions are negatively charged. Okay, they are negatively charged. Negatively charged. Now here, anion, when considering an anion, if the negativity increases, the stability decreases. What did I tell? When the negativity of this oxygen is increasing, the stability is going to decrease. So the charge given to it. Nobody likes to have a charge, right? So nobody likes to be negative. That's the point. Right? Nobody likes to be negative. If this R group is pushing more and more electrons to this compound, if this R group is pushing more and more electrons to this compound, to this oxygen's negativity is going to increase further. It's like everyone now. Now everybody have friends and family. Those people are there. Sometimes they just add negativity to you. Okay? Some people, okay, not everyone. Okay, some people are there. They are just pushing more and more electrons to you. So you are like being more negative and you are like being more unstable, right? So here, who is going to be unstable? Who is going to be unstable? A or B? Now you listen to my explanation, right? Who is going to be unstable? A or B? Who is going to be more unstable? A or B? A or B more unstable? A or B more unstable? So people who are not watching who are watching the recording doesn't get this voting thing. Huh? I am asking who is more unstable. Huh? Who is more unstable, A or B? Who is getting less electrons? So who is having more stability? So who is having less stability? The other way around. Okay. Come on. Come on, vote in the group. Come on, quickly. A or B more unstable? A or B more unstable? Vote करना Come on. Come on, everyone. Sharvi is sleeping. Zuha. And what do you have? Mokshi and Asmat and Sanduni. Sanduni, right? His name, I can't remember. Whoever. Mariam, and where are they now? What? What? Come on. Are you there? Hello? Shall I tell the answer? Shall I tell the answer? Okay, then I'll tell the answer. You're shy to vote or something. I can see that. Okay. Right. So what happens is this R group is pushing more electrons to this oxygen and this negativity of this oxygen is increasing and this one becomes more unstable and this one becomes more stable. So if a reaction is more stable, the products are more stable, that reaction is favored to forward. You will learn this in equilibrium also. So if this is stable, this reaction is more likely to happen. Now nobody likes to form an unstable compound. Okay, nobody likes to form an unstable compound. Everyone likes to form a stable compound, right? So what happens is this compound is going to form an unstable compound. So this reaction is less likely to happen and this reaction is more likely to happen, which means the acidity of this compound is greater than this one. Okay, acidity of that compound is greater than this one. Okay, that's the second explanation. That's the second explanation. Okay, if you want, just write it. If you want, just write it. Now only voting after I said the answer. After I said the answer, voting. Okay. Write this down if you want. Huh? Now we are moving into the next one, phenol thing. Okay, why are phenols? What about this phenol? Right. Now I said you, what did I say you? When the R group is thicker, bulkier, and more like it's like more bigger, longer, what happens is phenol CH3, CH2. I said you when the R group is increasing its size, the length, what happens? It's going to push more electrons, right? It's going to push more electrons. Now, what about this phenol? Phenol is, phenol, carbon, 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 double bond, single bond, double bond, single bond, double bond. Sorry, 1, 2, 3, 4. There's another one here. Single bond, double bond, single bond, double bond, single bond, double bond. Okay, single bond, double bond, single bond, double bond, single bond, double bond. Now, what happens if this compound is consisted with 6 carbon atoms and what I'm going to tell now? No, it's not like that. This compound, can you remember I said you that advertising thing, increasing the electron density in these positions. I mean ortho para positions, right? OH is increasing in ortho para positions. Okay, right. Now what happens? Is this phenol is not like the R group. What does it do? It will steal electrons. What does it do? It will steal electrons from this oxygen. The oxygen electron නැති වෙලා තියෙද්දි උගෙන් තව electron ගන්නවා. හරි? එතකොට මුට his angriness what happens? His angriness increases. ඒ කියන්නේ Arius එක වැඩි වෙනවා. හරි? ඒ කියන්නේ electron Arius එක තව වැඩි වෙනවා මුට වැඩි. දැන් මු electron දෙනවනේ he is going to give electrons. But what about this one? It's like not giving. It's taking the electrons already in the oxygen. Okay, then electron ඕන එකකින් තව electron ගන්න ගියාම ඌට තව තරහ යනවා. So what happens is this phenol is going to pull electrons from this oxygen and this oxygen's angriness increases and this one is going to be more acidic. Phenol is going to be more acidic than alcohol. Okay, phenol is going to be more acidic than alcohol. Right. Okay, that is the explanation. Huh? So he is going to move areas modern very, right? Like less acidic, this one more acidic. This one is more acidic. Write this down. Write this down. Right. Right then. After that, we are going to move into with this phenol thing, more deeper into phenol. Right. Write the topic: activators slash deactivators bonded to phenol. What? Activators or deactivators bonded to phenol. Now what are we going to do? Now you know activators. I taught you this in the third seminar. Okay. Not third seminar, second seminar. Second seminar I taught you. Not second seminar. First seminar day 2. Okay. First seminar day 2 I taught you this. What? Activators and deactivators theory. Right? Activators and deactivators theory. Now I am going to draw 3 compounds. OH, and I'm going to bond NO2 here, NO2 here, and I'm going to draw just a phenol, and next one I'm going to draw OH, and I'm going to bind the CH3 group here. Right. NO2 is a meta-director, ortho-para-director. It's a meta-director. You know that's a meta-director. What does meta-directors do? They will deactivate the benzene ring. What do you mean by deactivating? They will pull electrons from the benzene ring. So electrons, phenol also needs electrons. So what does it do? It's going to pull electrons more. It's going to pull electrons from the benzene and A carriers se cover කරගන්නේ oxygen ගේ. හරි? Oxygen ගෙන් electron ගන්නවා. Oxygen day ඔක්කොම දැන් ඔක්කොම මල ගන්නලා ඔක්කොම දැන් ඉවරයි. අන්තිමට hydrogen වෙනවා. Right? So he's like the most angriest one. Okay. Now he's like very acidic. He's like HCl, less than HCl, but it's out of the syllabus. You don't need to know it. Okay. It's like less acidic than HCl. It's like less acidic than HCl. And this one you already know. I'm just keeping that there. Okay. I'm just keeping that there. Then last one. Wait a second. Right. So this CH3 group is an activator. You know that it's a weak activator, but however it's an activator. It's a weak activator, but however it is an activator. Okay, whatever. Then CH3 group is going to push electrons to this benzene ring. Okay, CH3 group is going to push electrons to this benzene ring, and now what happens is the negativity of this benzene ring is going to increase. Okay, this negativity of this benzene ring is going to increase. Negativity of this benzene ring is going to increase. Okay. Now what? Now this is an activator and this is a deactivator. What does deactivators do? It will pull electrons. Not in orthopara. Yes, orthopara. Orthopara. So it's like pushing electrons into the benzene ring. Now the benzene doesn't want much electrons as before. Okay, but it needs electrons, but not much because it is already receiving from this CH3. It's already receiving from this CH3, so it doesn't need much. Now what happens is, now what happens is, now tell me who is going to be more acidic. This NO2 is pulling too much electrons. Okay, pulling too much electrons, and this oxygen is having the most carrier field. So this oxygen is less than this one. Okay, less than this one and less than this one also. So what is happening? This phenol is pulling electrons from this oxygen. True. This phenol also pulling electrons from this oxygen. And this phenol is pulling electrons from this oxygen. And who is pulling electrons from phenol? I mean from the benzene ring. NO2 is pulling electrons from the benzene ring. So this pulling will increase. So who is going to be more acidic here? The topmost one is going to be more acidic. This one, most acidic, number 1. Okay. Then next one is this one, number 2. Then this one, last one, number 3. Write this down. Write this down. Write this down. Come on. Write this down. Then finally, last one is going to be nitrophenol. In nitrophenol, there is another part we should discuss. Okay, there's another part we should discuss in nitrophenol. Don't worry that sound, okay? That's my dog shouting. Don't meet the pit, okay? It's not good to talk as dog. Okay? Done. Put in the group. Done or not? Done. Come on. If you are done, put in the group. If you are done, put in the group. Good. Okay, then what's that? Done. You also can get that sticker thing, huh? I also can get that sticker thing. In my phone, okay? Not in the lab. Now I am logged in by the lab. Right. Then nitrophenols. Now we are going to discuss about nitrophenols. What are we going to discuss about nitrophenols? Right. Now there are 3 types of nitrophenols according to the place where the NO2 binds. According to the place where the NO2 binds, there are 3 types of nitrophenols. Okay, OH, OH, OH. Now where I am going to bind this? Here, NO2, here, NO2, and here, NO2. I'll bind this here, NO2, and here, NO2. Okay, now tell me the names of these positions. What are these? Tell me the names of these positions. Tell Tell me the names of these positions. Okay. This one is going to be ortho. You know it. You know it. And this one is going to be para. Okay, pairing. So it's going to be para. So this is ortho, para. This one meta. This one meta, right? So this is the ortho para directing group. So electron most dense present here in the ortho para positions and not in meta. So electrons in a methionine, right? Electrons in a methionine. Right? Now this NO2 is bonded to a place where electrons are present. Without move adina කොට ඇදෙනවා. හරි? මොකක්ද කියන්නේ? අදින කොට ඇදෙනවා. What do you mean අදින කොට ඇදෙනවා? If electrons are there bonded to this position, if he pulls electrons, it's going to make the benzene ring lose electrons. Now if we consider him, where are the electrons located? Here, here and here. Therefore, at that it's like you go to an empty room and you ask people to come outside. Okay, there are no people here. So no matter how much he tries to pull electrons, it doesn't happen. But electrons at that so here NO2 is pulling electrons and adeno electrons, no electrons are coming out. Okay, no electrons what happens here? Ortho para. Electrons same as the first one, you can pull electrons from here also. You can pull electrons from here also. Right. Now, there is an intramolecular bond formation. What do you mean by intramolecular? Now, in your school, there are intra-school things, right? Sports meet. So, in the school itself, there are 3 houses. So, what you do is you compete with each other, and you like have a cup or something, and cup means the lifting cup. Okay? So, the winner gets that one, then the runners up, then the third place. Like that's like intra-school. So, what do you mean by inter-school? Inter-school means inter-school rugby championship, right? So the inter-school cricket championship, the big match. Okay, the big match. So our big match is coming soon. Okay, that's another story. So what happens is this molecule, a certain molecule, can form bonds with another molecule, and this is known as intermolecular forces. Then intramolecular, in biology you learn this, like intrafascicular cambium, interfascicular cambium, we learn this. Okay? So inside the molecule, if let's say there is hydrogen, there is OH, so this one makes the intramolecular bond. So here it is like an intramolecular bond formation. Intramolecular bond, hydrogen bond formation actually. Okay, hydrogen bond formation here. I will tell you about hydrogen bond formation in boiling point variation, like exactly what is this hydrogen bond formation, and like there are 2 things which you should know about hydrogen bond formation. 2 things which you should know about hydrogen bond formation. Okay, so here is a intramolecular bond, but there is nothing. Like that it happens if you see a girl, you like make a bond with her. I don't know about that. It depends on you. Okay? So like this OH cannot see this NO2, which is why it is on the other side. This OH can see this NO2, so there is a bond formation. Now what I am going to tell you, this hydrogen doesn't like to leave because there is a bond form. This hydrogen doesn't like to leave because there is a bond form. Now this explanation is not that simple. Okay? It's like to like make you understand actually what's happening. It's like the made up theory explanation. Okay, it's like a made up explanation. So what's going to be the most acidic here? What's going to be the most acidic? Para. I need to fill this marker now. Okay, para. Then after that, because it's like pulling electron, මේකේ ඇලියස් වැඩි වෙනවා. ඒකට ඔක්සිජන් ගෙන් අදිනවා. ඒකට හයිඩ්‍රජන් හොයන්නත් නැහැ. හරි. ඊට පස්සේ මෙතන ඇද්දට ඇදෙන්නේ නැහැ. ඒ චුට්ටක් ඇදෙනවා. හරි. චුට්ටක් ඇදෙනවා කියලා කියන්නේ. හරි. ඒකට මෙයා අන්තිමට එනවා. right? These should come last. What? Meta. Okay? Meta. Okay, meta. And here in the middle, ortho. Right? Ortho. Right? Acidity most in para nitrophenol, then after that orthonitrophenol, then finally meta nitrophenol. Write this down. Immediately නැහැ මේක තින්ත දාගන්න. If you are done, tell me. If you are done, tell me in the group. Okay. Okay. Right. Then phenol කතාව ඉවරයි. හරි. මොනවද? phenol වල කතාව මොනවද? ඉස්සෙල්ලාම නිකන් phenol we should distinguish. First you have the main variation, right? ඔන්න පොඩේ උඩ ලිව්වි තනියට මොනවද? main variation එක. අපි මොනවද කතා කරේ? alkyne discuss කරා. aldehyde ketone වල මුකුත් නැහැ syllabus එකේ ඉච්චර ලොකුට දැනගන්න. but you might think that it will react with sodium hydroxide. Can you remember that aldol condensation reaction? That's a different thing. That is not connected with acidity thing. Okay, that's not connected with acidity thing. It's different. It's something very different. Okay, not connected to this acidity thing. That is condensation reaction. Just separate that from acidity. Okay, so like aldehyde ketone are like more acidic than alkaline. Then after that comes alcohols. Okay, after that comes alcohol, except methanol, other things. Then more than alcohol, you have water. Then after that you have methanol, and after that phenol, and finally we are going to go into carboxylic acid. So why this carboxylic acid is the highest? Why this carboxylic acid is the highest? There should be a reason, right? This carboxylic acid is like the highest one. Why? Now there are two explanations. There are how many explanations? There are two explanations to explain this. Okay, there are two explanations to explain this. So carboxylic acid. What is this? Carboxylic acid. I'm going into explanation one now. So this is CH3, C double bond oxygen, OH. Hurry. Then what happens is this oxygen is going to pull electrons. Okay. And what will happen to him? No one to give electrons. See? No one to give electrons to that oxygen, right? No one to give electrons to this oxygen because this carbon is busy providing electrons to this oxygen, and this pushing also doesn't affect much. But actually, when R group size increases, what happens is acidity decreases. So when this carbon donates these electrons towards this oxygen, he will receive only little amount of electrons. So AIS cover the hydrogen. So he is like more acidic. Okay, there's an explanation. No one to give electrons to oxygen bonded to hydrogen. No one to give electrons to oxygen bonded to hydrogen. Therefore, oxygen takes all the electrons of hydrogen and makes it liberate. That's it. Okay, that's all. Then there's an explanation 2. What is the explanation 2? Okay, first just write this down, write the compound and draw this electron pulling thing. Okay, electron pulling thing, and write no one to provide electrons to oxygen bonded to hydrogen, because carbon is providing electrons to the oxygen above it. ඒක අර නිකන් ඔයාගේ වචන වලින් ලියන්න. ඒ කියන්නේ තේරුම් ගන්න ලියන්න. ඒක එක්සෑම් එකට ලියන්න නෙමෙයි. හරි තේරුම් ගන්න. එක්සෑම් එකේ අහන විදියට ලියන්න. Resource book එකේ තියෙනවා method එක. කියන්නේ ඒක writing in words there's a special explanation method. You can refer marking schemes to do that. Okay, refer marking scheme to do that, and the resource book you have, resource book also there is. If I have time, I will give you a tute for this. Okay, tute for this with the proper explanations. Okay, proper explanations. I'll give you a tute. Right. Write this down quickly. Quickly. Finished in the group. Come on. Right. It's an open link today. Okay. Right. Then after that is second explanation. It's like the resonance one. Okay, this is like the logical one. This is what's there in the resource book. This is what's there in the bigger than this marker. Okay, this is CH3, C double bond oxygen, OH. Right. Then pain actually. I'll write it blue color. C double bond oxygen OH. Okay, C double bond oxygen OH, and it's going to liberate the H plus. It's going to liberate the H plus, and it's going to form this compound O minus. And you can see, you have learned in Lewis structures that this compound can stay in resonance. So it is resonance stabilized. So it's like, unlike that phenol and that alcohols, these are resonance stabilized. That is like more stable. It's like more stable. What do you mean by resonance stabilized? You can draw 2 resonance structures for this compound O minus here, and there's another one CH3, C double bond, single bond oxygen minus and double bond. Okay. So this is the resonance structures for carboxylic acid. Resonance structures for carboxylic acid. Therefore, this is stable. This compound is stable. Okay, this compound is stable, and this reaction takes place forward. It tends to happen forward. So here also, when the R group is getting larger and larger, the electron pushing is increased. And therefore the acidity is going to decrease, right? The oxygen's angriness. Okay, if oxygen receives electrons, is going to be less acidic. If it doesn't receive electrons, it's going to be more acidic because it's angry. And it is showing more acidity. It will take the electrons from the poor hydrogen, and this hydrogen will have to go away. That's it. Okay. Now the surprise compound. Finally, write this down. Right, this done. Now only people are voting. What do you like more, acids? Everyone like acids, eh? See, acids are the bad people. Now today you learned it. Acids are the bad people. Okay, acids are the bad people, and bases are the good people. So you should be liking bases more because bases are like ඔය එළියන H+ අල්ලගෙන ඉලෙක්ට්‍රෝන දෙනවා. එච්චරයි. හරි. එළියන H+ එකක් අල්ලගෙන ඉලෙක්ට්‍රෝන දෙනවා. අර ගෙවල් නැති කට්ටිය ගෙවල් දෙනවා. හරි. Like that. Okay. So, write this down. Then the surprise compound, we are going to go into the surprise compound. I think I put into a wrong mark. Right. Then finally, now only good. Now only the marking is okay. Okay. Finally, you have this compound, the surprise compound, the final box. Okay, the final box. Now, who is the guy who is more acidic than everyone? Acetate. Why do I say that? Hurry. Ayya, where is this hydrogen thing? Okay, you will ask that. CH3, C double bond oxygen, chlorine. Now, what did I say? I said that liberating H plus and gaining H plus is acidity or basicity. So, what are you telling? There is no hydrogen here. Yeah, there is no hydrogen. If this one was added to water, what happens? It's going to form OH plus HCl. You got that? It's going to produce carboxylic acid and this very strong acid HCl. It's going to form a very strong acid which is HCl, and it's going to form the carboxylic acid when reacted with water. Okay, when reacted with water. Inside the box, write this everything. Huh? Write everything. CH3, C double bond oxygen, fluorine plus H2O. When it gets reacted with water, it forms this compound, carboxylic acid, and a strong monobasic acid, HCl. Strong monobasic acid, HCl. Okay, did you understand? Yes or no in the group? Did you understand? People who are in the meeting? Did you understand? Everyone, come on. Come. Crystal clear, right? Others, come on. Who are there in the meeting? Asmat and whatever. Others. Come on. So acidity variation. That's like awkward, nahi? Crystal clear thing. Right. Acidity variation done. Okay, acidity variation is done. Now we'll move into basicity variation. Right. Starting basicity variation. Okay. Okay, then the basicity variation I will move on. Right. Now you need to know one thing. First, one thing you need to know: all nitrogen-containing compounds they have some quality. What is the quality they have? You know, oxygen you learn from the acidification. Oxygen learning are low by your electrons gone. Electrons gone. Because but nitrogen is someone who likes to give electrons to others. It's like donating, charity work. Okay, this nitrogen is like more charity. He does more charity stuff, and he's like giving electrons to others. He is like giving electrons to others, but oxygen is not giving electrons to others. Right? It's not giving electrons to others. You can compare this. You can compare this thing with this reaction. Now write the topic basicity variation. No? Write the topic basicity variations. You have ROH, right? You have ROH. Now what is basicity? Gaining H plus. I said you that in the beginning. Huh? What is basicity? Gaining H plus H plus is going to go into R O hydrogen and it's going to create a positive charge on oxygen. It's going to create a positive charge on oxygen. Now what about RNH2? What about RNH2? R nitrogen, hydrogen, gaining H plus, right? I said you know, කොහෙවත් යන H plus එකක් අල්ලගෙන electron එක දෙනවා. හරි? electrons මොකද දෙකක් තියෙනවද නේද? He has 2 electrons here, he has 4 electrons here, but he doesn't like to give. You can see the reason here. Oxygen gets a positive charge, but here nitrogen gets a positive charge, and that's like okay. Now in when drawing Lewis structures, you can see there are sometimes in nitrogen positive charge, and it's like you don't care about it much, right? It is usually stable. This is more stable. This is more stable than this thing. So this reaction is more favored than that one. So oxygen doesn't like to give electrons. Oxygen doesn't like to give electrons. It's like the world's second highest electronegative element, and after that nitrogen is the third highest electronegative element, but it like donates. It likes to donate. Okay? It likes to donate. It's like not stingy like this oxygen, it likes to donate. That's it. Okay. So from this you can conclude that all nitrogen containing compounds are more basic than oxygen containing compounds. Right? I reason again අපිට තේරෙන විදිහට reason එක මොකද්ද? Nitrogen is not stingy. It is very charity. It likes charity. It likes to give electrons to others. But oxygen is like needy. It's like acid, more acidity. I said you acid, being an acid is a bad thing, and being a base is a good thing. So if from today you should like good things. Okay, like good things. So you should like basicity more. Right? So you should like more bases than acids. Right? So all nitrogen containing compounds are more basic than oxygen containing compounds, and this is the theoretical reason. Because there are no other reasons we give this explanation, but you can't exactly explain why this nitrogen acts like this and oxygen can't act like that. Okay, there is no proper explanation, but this is the accepted explanation for today. Okay, for today means not only today, these days. These days the accepted explanation is this one, in chemistry. Okay, that's it. So write this down. Write this down. Write this down. Write this down. Right. When do you want an interval? Let's take at 8 or something. Still 7:45. Right. Then we will move into. Now we are going to discuss only nitrogen containing compounds. There are no oxygen containing compounds in basicity variation. There is no oxygen containing compounds in basicity variation. So what are we going to discuss? These compounds. Amines. We are going to discuss about amines. We are going to discuss about amides. We are going to discuss about amines. R nitrogen, R carbon double bond oxygen NH2. This is amide. I said to you. What did I say you? Amide. This letter D represents a double bond, right? This letter D represents double bond. That's how we that's how we separated this. Okay, this D represents a double bond, and this one doesn't have a double bond, so it is called as an amine. Okay, this D goes up, like amide. Writing in amide. This D goes upwards, so this carbon has a double bond oxygen, so that's creating this up thing. So we are like remembering amide from that. So later you don't need this. Later you will be more good with organic. So after that you don't need these tricks to remember. So we are going to discuss this one, and we are going to discuss a special compound. I mean a special amine. Special amine is special NH2. Right? These three compounds we are going to discuss. Okay. Now, other than that, there is ammonia also. We are going to discuss all these four. Okay. Now I will draw all these compounds in the board. Okay, I will draw all these compounds in the board. Nitrogen, hydrogen. There is a double bond here. And then you have aniline. You have aniline, NH2, NH. Okay. Then after that you have R, NH, H2. Then you have RC double bond NH2. Right, RNH2. Then we are going to move into each of these compounds. We are going to look what happens to that acidity variation. Okay, we are going to look at what happens. Now what is not acidity, basicity variation. Now what is basicity variation? Basicity variation means gaining H plus, right? So gaining H plus. So he is going to gain H plus. Now the ability of gaining H plus, I mean the ability for a compound to gain H plus depends on whether it can give or not, right? If you know something, you can teach others. If you don't know anything, you can't teach others. So this nitrogen should have electrons to provide. If it doesn't have electrons, how can it provide? It can't do that, right? So if somebody is putting electrons from nitrogen, then nitrogen's ability to donate reduces. It's logical, very logical. Just listen and it's going to be very logical. So this nitrogen, if it's like somebody is pushing electrons to him, I mean giving electrons, he will be like more happy. He's like he can donate more because somebody else is giving. Think like you're giving some beggars money. Okay, some beggars you're giving money. This money is electrons, and you are this nitrogen, right? And these beggars are H plus. Okay, now you are giving this money to these beggars, and you have certain amount of money you give them. But what if someone steals from you that money? Then you can't give, right? You can't give. Now you also have to go and beg somewhere. Keep handkerchiefs and beg. So if someone gives you electron, your friend, okay, Majan, keep this 100 rupees and give him that one. Okay, some people are like that. Okay, some friends they don't exist, but they are there. Okay, somewhere they are there in the paradise or somewhere they are there. Majan, keep this 100 rupees and give that beggar. Okay, something they will there. So likewise, if this nitrogen is getting electrons from somewhere, it likes to donate. If somebody stealing electrons from it, it doesn't like to donate much. Okay, do you get it? Right. Then we are moving into this H plus thing. Now ammonia is liking to donate H plus, and you know this ammonia thing, NH3. If you have done pH, okay, if you have done pH, it forms NH4 plus. You know, this is a bit more stable compound. It's anion actually. Cation. This is cation. Okay. So it's like normal. Let's think it's like normal. This is a normal value. Okay, normal thing. Now when it comes to here, before that I'll go into here. Because there's a point here. I'll draw this aniline here. Aniline, and here R. Okay. Now what? So this ammonia is gaining H plus. Okay, ammonia is gaining H plus. I'll tell that as normal. That's like the baseline value. Okay. Where is ammonia? Baseline. This is the baseline. Then in physics you take as GPE0 line. Likewise, ammonia I'll take as a baseline. Then I'll move into this one. Now what about this R group? R group, what does it do? I'll tell you. I told you R groups are pushing electrons. R groups are the people who are pushing electrons. Electron only the electron they know. They are like good friends. They are like giving electrons to others. Okay, what happens? This R group is giving electrons to this nitrogen, and nitrogen's negativity increases, and it has more money. Money means electrons, so it can donate. So he has more acidity than this ammonia. So RNH2, I'll move here. Okay, it's like the baseline is the up. This like positive, this like negative. Okay, just. Now going into this one, I will put this as baseline. Not that this is base, not like that. Baseline means the zero line. The zero line just I am taking. Okay. Then this RNH2 is above this one. Okay, because this R is giving nitrogen some money or the electrons, so it can donate. Here what happens? He is like taking electrons from this nitrogen and not letting him donate. Okay, he is not letting him donate. So basically it's going to reduce. So it's like going below. Aniline is less basic. Why? Because this benzene ring pulls electrons from this nitrogen, and what happens is, let's think he has 1,000 rupees. He has 1,000 rupees, and this benzene is taking 800. Okay, he is taking 800. He's taking 800, and now he has only 200. So if he doesn't have electrons, how can he donate? So his basicity is going to reduce. Now what is basicity? It's like giving electrons to someone or gaining H plus, right? Giving electrons to someone who doesn't have electrons and bonding him together with him. That's what he does. It's like a good thing, and he's not letting him do it. So it's like going down the baseline. Ammonia, this is benzene and NH2, this aniline, and this is amine. Then finally this one. Now this one, it's like a special case. Now there is the knot. Okay, there is the knot. Right. Now this one is also based on what? Resonance structures. What do I mean that? This one is also based on resonance structures. Now think this compound is existing in a resonance structure. R, C double bond oxygen and nitrogen NH2 like this. So it exists in a resonance. It exists in a resonance. How? R, C, it gives a negative charge to oxygen and forms a double bond with nitrogen. Okay? Forms a double bond with nitrogen and gives a positive charge to this nitrogen. Now you can see there is a positive charge given to nitrogen. So what is my positive charge? It's like you don't have electrons now, right? So actually these resonance structures are there, right? So the real compounds, they are made from the average of these two resonance structures. What do you mean by that? Make compound actually. So actually this nitrogen is having a positive charge. What? This nitrogen is going to have a positive charge because of this resonance thing. Okay, because of this resonance thing, this one is going to have a positive charge on nitrogen. So it's going to have a positive charge on nitrogen. So this reduces the basicity of this, what we call amide. So amide is even lesser than this, R C double bond oxygen NH2. So who is like the most basic? RNH2. So after that ammonia, and after that aniline, and after that this compound, what? Amide. Okay, amide. Now this is what they have taught in the resource book. This is all. But there is something else we need to know. This tertiary, secondary, and primary amines. Now this guy has three types. I mean, primary means this one. If there are two R groups bonded, there is secondary. Then after that three. Likewise, there's another variation. We'll look into that later. For now, write these four compounds. Okay. But write these four compounds and write this H plus thing and draw arrow like thing. I'll give you 1 minute to do that. Okay, 1 minute to do that. You can write these four compounds and keep some lines below that. I'll give you few sentences. Okay, underneath each, I'll give you few sentences, 1 or 2 sentences like this. Leave space beneath all compounds, and you can write something beneath that. Okay, right. Draw these four compounds. Right? Okay. Now underneath ammonia, this one, make underneath ammonia, right? Underneath ammonia, right? No R groups to donate electrons. No R groups to donate electrons. No R groups to donate electrons. But somehow it will donate the electrons to H plus. But somehow nitrogen will donate electrons to H plus. But somehow nitrogen will donate electrons to H plus. Right? ඊට පස්සේ මේක හරි නිසුනා නම් පොඩ පිටිපස්සට ගිහලා බලන්න පුළුවන් YouTube එකේ. හරි. Then after that, right under this one, right under the second one, okay, මේකේ හරියට බලන්න මේකේ R group, the R group supports nitrogen. The R group supports nitrogen by donating him electrons. The R group supports nitrogen by donating him electrons. The R group supports nitrogen by donating him electrons, which promote the electron donation of nitrogen, which promotes the electron donation of nitrogen, which promotes the electron donation of nitrogen to H plus, which promotes the electron donation of nitrogen to H plus. Therefore, amines are more basic than ammonia. What? Amines are more basic than ammonia. Therefore, amines are more basic than ammonia. Okay? Amines are more basic than ammonia. Amines are more basic than ammonia. Then under this one, make a hurry. This one done. Then under this one, third one, there is a benzene ring attached to nitrogen. There is a benzene ring attached to nitrogen. There is a benzene ring attached to nitrogen. This benzene ring steals electrons from nitrogen. This benzene ring steals electrons from nitrogen. The exam එකේ ලියන්න එපා steal කියලා. I'm just telling you the things like in basic idea for you to understand the variation. Okay. This benzene steals electrons from nitrogen, reducing the available electrons to nitrogen, reducing the available electrons of nitrogen to donate to H+. Right? To donate to H+. Right. Therefore, aniline is less basic than ammonia and amide. Therefore, aniline is less basic than ammonia and amide. Aniline is less basic than ammonia and amide. Right. Then that one done. Then this one, carboxylic acid. Not carboxylic acid, amide. Sorry. This one. Amide exists as a resonance. As shown below. C double bond oxygen, nitrogen, hydrogen. The resonance, draw this. R, C, single bond oxygen, negative charge, double bond hydrogen, plus. Draw these two resonance structures after it. Okay. Draw these two resonance structures. As you can see, then write, as you can see, the nitrogen gets a positive charge. Therefore, the basicity of amines are less than aniline, primary amine, and ammonia. Right. Then write this variation. I mean the basic variation. You need to know it. First, who is the most basic? I said you, amine is going to be the most basic. RNH2, most basic. After that comes ammonia. Then after that, after that comes ammonia. Yes, this one. What is that? Aniline. This is amine, this is ammonia, this is aniline. NH2. Then the least one is amide. RC double bond O NH2. What is this? Amide. This is aniline. This is ammonia. and this is amine, and this is amine. Write this down. Write this down. Okay. Now write the topic. Now write the topic. Variation of basicity in primary, secondary, and tertiary amines. Basicity variation of primary, secondary, and tertiary amines. What? Basicity variation of primary, secondary, and tertiary amines. Right? Primary, secondary, and tertiary amines. You are going to see the basicity. Right? Now, I'm going to draw. This is RNHH. So this is primary, one R group. So this is 3 R groups, and this is 2 R groups. Right. Now what? Now, as our theory suggests, now we build a theory, right? R group is pushing electrons, so it is helping in nitrogen to donate electrons, right? So he is pushing electrons. So yeah, there are 3 people pushing now, and there are 2 people pushing here. Okay, there are 2 people pushing here. So as you can see, who has the most basicity? You might think he has the most basicity. No. Why? There is a reason. There's a special note for this. But it's like out of the syllabus, it's like out of the frame, out of the reading frame. It's like this tertiary amines have 3 bulky R groups which reduce the ability to donate electrons. But this tertiary amines have 3 bulky R groups which reduce the ability to donate electrons. He is the highest one. He has 2 people donating him. So it's the highest. After that him. After that only him. Okay. So secondary amine is the highest. After that tertiary amine, and finally primary amine. Okay, MCQ. They will ask this in MCQs and stuff. So you need to know it. Right? So what? Primary, secondary, tertiary. Who is the most acidic? The secondary one. After that, tertiary one. After that, primary one. Like this reason also. These primary amines have 3 bulky R groups which reduce the ability to donate electrons, which means it is less basic than this secondary amine. Okay, less basic than the secondary amine. Write this down. Basicity variation is done now. There's a small thing which you should know. Okay, there's a small thing which you should know. What you should know? There's another point you should know. Like this is clear one screenshot tag right. Then there's another point you should know. This annealing thing. There's another variation. Now this is just aniline NH2. Okay, this is just aniline. Then there is this NO2 group binded. අර වගේ තමයි ෆීනෝල් එක වගේම තමයි ෆීනෝල් එක වගේම තමයි. So here there is a CH3 group. Right? NH2. Then මෙතෙන්ට ඕතෝ බැලලා කතාව ගාව ගන්න එපා. හරි? That one we consider when the same NO2 binds to ortho para positions. When the same NO2 binds to ortho para positions. And now what happens? Then මොකක්ද theory එක? Basicity කියන්නේ ability to donate electrons. ඒ කියන්නේ තව H එකක් ගන්න එකනේ. හරි? තව H එකක් ගන්න එක. මුට electron දෙන්න තියෙන ආසාව. හරි? electron දෙන්න තියෙන ආසාව. කැමැත්ත. Charity work. Okay? Now what does this phenol do? Phenol is pulling electrons. Phenol is trying to pull electrons from this nitrogen. And this NO2 is a deactivator. What do you mean by deactivator? It's pulling electrons from the benzene ring. It's pulling electrons from the benzene ring එක හිතනවා යමෝ දැන් මං ඉලෙක්ට්‍රෝන අදින්න යන එක වෙන එකක් කලිනවා. ඒතර මම මොකද කරන්නේ? He will pull more electrons from this nitrogen. Okay, he will pull more electrons from this nitrogen. මොකට දෙන්නේ ඉලෙක්ට්‍රෝන නේද? ඔව්. හරි. Now he doesn't have electrons to donate. Now what happens? Now here just pulling electrons, not much than him. මෙයාගේ තරම් අදින්නේ නැහැ චුට්ටක් අදිනවා. හරි? Not much. Here what happens? This CH3 group is providing electrons. Hari hondai. Hari I like people like this. Okay. So like, there are some friends who give you money. So the CH3 groups are something like that. They are activators, right? They are activators. Right? They are activators. Also they push electrons to the benzene. Right? Benzene is like okay now. So he will pull little bit of electrons only. Hari. So වැඩියෙන්ම electron අදින්නේ කාගෙන්ද? මූගෙන්. ඊට පස්සේ වැඩියෙන්ම මූගෙන්. අන්තිමට මෙයාගෙන්. So when we pull electrons from this nitrogen, what happens? Nitrogen the ring electron නැති වෙනවා. Basicity අඩු වෙනවා. Therefore least basic is this compound. And after that this one, then finally this one. So basicity is increasing in this order. What order? This order. Basicity increase. Logical lah. What logical? Scene එකකින් නෑ. මොකද්ද? NO2 අදිනවා electron. අදින පාරට phenol is getting more positive, so it's like pulling more electrons from this nitrogen, and this nitrogen doesn't have electrons to donate. So here it's pulling electrons from this nitrogen, but not much as seen, because like phenol, nobody's going and coming and pulling here from phenol. And here the donating guy, the good guy is there, so the good guy gives electrons to the benzene ring. And it makes it more negative, and he's like more happy now. What electron? So it's like okay now. So this nitrogen is okay now. He can donate electrons. He can donate electrons more easily than these two. So write this. Write this. Write this. Write this. Write this. Write this. Right, now we are going to start. Now we are going to start. Now we are going to start the what? Ultra power short notes. Now I'm going into the short note thing now. Now this is more important to the people who joined the seminar. This is more important to the people who joined the seminar. So this is the seminar, I mean the paid seminar. If you want, you can take the recordings of that. All reactions are completed. You can complete in organic. You can complete organic before everyone else if you take the recordings. Okay. The reactions, all reactions were done there. Okay. All reactions were done. Right. I'll inform in the group. Okay. Now we are going to start the ultra power short note thing. Okay. So first one, we are going to like connect that brothers. Who are the brothers? Alcohols, aldehydes, ketones, carboxylic acid. Those guys, we are going to connect them. Okay, I mean that one is most important. I mean this short note is going to be the most important one. Why? Here is CH3, CH2OH, let's say. And this one's aldehyde, I am going to write CH3, C double bond oxygen, hydrogen. And here you are going to have CH3, C double bond oxygen, OH. Okay. So this is like the alcohol, and this is aldehyde, and this one carboxylic acid. Right, carboxylic acid. Now you can write the conversions of these things. You can write the conversions of these three things. How? You can go from alcohol to aldehyde, but you put anhydrous, PCC. What? Anhydrous PCC. How do you go from this one to this one? You can put anything, not anything. H plus came in O4 or H plus Cr2O7 2 minus. Likewise, I gave a list of oxidizing agents for here to use. That one I gave in the seminar. Okay, that's another short note. If you want, you can take that also. Then here H plus KMnO4. Okay. Now what you can do is you can go from here to here, but not from here to here. This path is not possible. Not possible. Okay. This path is not possible. You can't go from carboxylic acid to aldehyde. You can go only from carboxylic acid to alcohol. That's the only way you can go. What do you put here? You put lithium aluminium hydride dry ether and H2O. What's the special point? You can't use anything else. This is the only reducing agent which can be used. What? Only reducing agent which can be used. Okay, only reducing agent which can be used. Only reducing agent which can be used is this compound. Okay, not compound. This mixture is the only reducing agent which can be used. Right, write this down. This is the first one. Okay, this is the first one. This is going to be the most important thing you will write. Conversions conversions duanne. It's like the petrol of the conversions. Okay, petrol of the conversions. What is wrong with that? Wait a second, I'll just go and look. Okay. Okay, given, done, right? In the group, everyone in the group. Done the dual. Done. done the finish the live other go. Come on. Yep. Okay then next one is the other important thing you need. It's like the tires of the conversion. Okay? It's like tires of conversion. It's like the most used. What is the most used? The Grignard reagent. So how do you produce the Grignard reagent? From this compound, what do you call this? Alkyl halide. What do you put? Magnesium dry ether. What do you put? Magnesium dry ether. Then you get CH3, CH2, MgCl. CH3, CH2, MgCl. So what you can do to this? First, number one, what you can do is you can put aldehyde. That is like obvious, you know it, right? R, C double bond oxygen, hydrogen, right? This is R, C, okay? So what I'm going to get? This one goes into OH and there's CH2, CH3 binded, it will go and attack, then attach. I said you in the seminar, what will they do? They will attack and attach and it will keep the remaining groups there. Okay, aldehydes and ketones. Aldehydes and ketones. Aldehydes and ketones. So here, next one I will take an ketone. R, C, double bond oxygen, R. So what? And you put water. Don't forget you put water. Water is there. Without water, it's going to be OMgCl. Water is there. Hydrogen is hydrogen is H2O, H plus, O, H3O plus, whatever you can put there. It should be a hydrogen provided. Then H2O, R, C, this one OH, R, then CH2, CH3. හරි දැන් මේ බයින්ඩ් වෙන එක මම කලර් කරනවා. හරි දැන් බයින්ඩ් වෙන එක මම කලර් කරනවා. මම මේක බ්ලූ කලර් දානවා. හරි මෙතන බ්ලූ කලර් සෙට් එක ගෑල්ල. මේ සෙට් එක ගෑල්ල මම දානවා බ්ලූ කලර් එක. Okay. Then next one is acid halide. This is the important one. Acid halide. This is RC double bond oxygen, chlorine, and for this, if you put what Grignard reagent, number one, number two, water, and you get RCOH and CH2, CH3. I said you, when this CH2, CH3 is attacking and attaching, what happens is he doesn't like this chlorine to stay. Okay? He doesn't like this chlorine to stay, so he chases him. So what happens is there are two CH2, CH3s are going to bind here. That's the special point. That is the special point. Acid halide, it's like it attach, but it wants another one there. It wants another compound to be there. So there's two, attacked and attached. Right? That's another one. What's the other one? But don't forget to write this water. Okay, water everywhere you should put water. Don't forget. OCH3. What is this? Ester. We learned this. Ester. Right? Ester. Then next one we put water. What do you get? R, C, OH. Same like this reaction. CH2, CH3 attack and attach, and it doesn't like this OCH3 to stay there. So, pong or go. I don't know Tamil. Okay, pong or go or whatever you tell. It's going to leave. It doesn't like to stay. CH2, CH3, CH2, CH3. Okay, CH2, CH3, yeah, CH3. Right. Nigga, write this down. Huh? Write this down. right? So ultra power short knots දෙක හරි. මේ දෙක හරි. හරි. then diazonium short knot එක දුන්නා කලින් ඈ. ඒක කලින් දුන්නා මේ සෙමිනාර් එකේ දුන්නේ. හරි. ඒක කලින් දුන්නා. right. then now we are going to look into the identification. Right, identifications in organic. Okay. I'm going to erase this one. Right. Now, organic identifications. මේ ටික දැනගන්න ඕනේ. හරි? මේ ටික දැනගන්න ඕනේ. හරි. දැන් අර acidity variation එකේ in that acidity variation there is a table you need to draw that comes under identification. That's why I kept it for later. You need to write this down. What you should write? This variation or this table. So you have first sodium, then sodium hydroxide, then sodium carbonate. Okay, these are the compounds we are going to put. We are going to put sodium, then sodium hydroxide, then Na2CO3, or you are going to put NaHCO3, right? Now you are going to look at what happens when you put these three compounds into different compounds, and you are going to look at the changes taking place. CH3, C triple bond carbon hydrogen. Here there is a terminal hydrogen. I said here this is less acidic than water. Okay, it's less acidic than water. It's going to react here. It's going to react with sodium like metals. CH3, C triple bond C, Na plus hydrogen. This evolution of hydrogen is the observation. Right? Evolution of hydrogen is the observation. මේකේ මුල් color එකක් එහෙම මුකුත් දෙන්නේ නැහැ. හරි? This hydrogen evolution එකක් තියෙනවා. Hydrogen evolution එකක් තියෙනවා. ඒකට ඒක observation එකක්. It doesn't react with sodium hydroxide. It doesn't react with sodium carbonate. ඇයි sodium hydroxide react කරන්නේ නැත්තේ? Why doesn't it react with sodium hydroxide? Because මෙයා ඇත්තට වැඩක් නෙවෙයි. Now water වලට වඩා less acidic නම් water sodium hydroxide දෙක react කරන්නේ නැත්නම් මුළු ලෝකෙත් react කරන්නේ. You won't react. කොහොමද react කරන්නේ? එතකොට they won't react with sodium hydroxide and sodium carbonate. ඊට පස්සේ next one is දැන් අර table එක මතක් කරගන්න. aldehyde ketone ඉන්නවා ඊට පස්සේ. ඊට පස්සේ ඉන්නවා aldehyde ketone react කරන්නේම නැහැ. කියන්නේ මොනවද මේ aldehyde ketone doesn't react with sodium hydroxide sodium carbonate, but it will react with sodium. Next time I'm going to go into alcohols. Okay, මේවා තමයි දැනගන්න. aldehyde ketone sodium reaction එක දැනගන්න ඕනේ. හරි? CH3 CH2OH. Right? CH3 CH2OH. You are going to put sodium. What happens? It's going to replace this hydrogen with the nitrogen. CH3 CH2O Na plus minus. Right? Plus H2. This is the identification. Then it doesn't react with sodium hydroxide. It doesn't react with sodium carbonate. Right? It doesn't react with sodium hydroxide. It doesn't react with sodium carbonate. ඊට පස්සේ යනවා අපි කවුද ඉන්නේ ඌට වඩා වැඩ water ඉන්නවා water වලට පස්සේ ඉන්නවා methanol අපි මේ දෙකම skip කරලා යනවා phenol වලට මොකද practical එකේ අපි කරන්නේ මෙන්න මේ ටික විතරයි මේ practical එකෙන් ගන්න answers ටික හරි we are doing a practical at school which we do by these three compounds. We are putting it into this alkyne and we are putting it into an alcohol, we are putting it into a phenol, and finally we are putting it into an carboxylic acid. Okay, this is the practical. So this comes under identification. Huh? This comes under identification. So you have phenol, okay, OH. So what happens? It's going to react with sodium. It's going to react with sodium. O minus Na plus hydrogen is going to release. Okay, what? Hydrogen is going to release. And here also it's going to react phenol O minus Na plus hydrogen and it doesn't react with sodium carbonate. අරකට එක්ක රියැක්ට් කරන්නේ නැහැ මේ දෙක එක්ක රියැක්ට් කරනවා. කියන්නේ obviously more acidic than මේ කට්ටිය. හරි. මෙයා sodium hydroxide එක්ක deal කරන්න දන්නවා. He doesn't know how to deal with sodium carbonate or sodium bicarbonate. හරි. කට්ටිය ඊට වඩා වැඩි ටිකක්. හරි. Then finally you have the one which you want, I mean the strongest one, CH3COOH. Then OH කියන්නේ C double bond oxygen OH. කියන්නේ carboxylic acid. හරි. Carboxylic acid, once they react with carboxylic acid, what happens is CH3 C double bond oxygen O minus Na plus. Hurry, O minus Na plus hydrogen release. Then here sodium hydroxide, same reaction, CH3 C double bond oxygen O minus Na plus hydrogen. Here also CH3 C double bond oxygen O minus Na plus and plus hydrogen. Write this down. Identifications in acidity. Acidity identification is organic. Identifications in organic එකේ පළවෙනි ගාල්ල. මේක first part එක. කියන්නේ acidity වලනවා compounds වල. හරි. Write this down. Hurry. You wrote me? Right. Then ඒකෙන් ගොඩක් ඒවා cover වෙනවා මේ table එකේ තියෙන. හරි. Lot of things are covered from that. Hurry. Now I'm going to erase this. Now I'm going to erase this. Right. Now I'm going to write a table. I'm going to write first one the test. Then I'm going to write observation. Then third one the compound. Alright, we are going to identify with the test, observation and compound. Make a දෙවෙනි එක. දැන් පළවෙනි එක මොකද්ද? acidity එක්ක බලමු එක. Right? With acidity we looked at the differences and now we are looking at other things. We are like comparing things නේ අපි බලන්නේ මොනවද? එක එක දාලා මොකද වෙන්නේ කියලා බලලා. That's how identification are. We don't know what's the compound in the test tube, but we put different compounds and we see what it is. So we are like looking what will react and what are the definitions we can get. This is very important in isomerism question. Okay, very important in isomerism question. They will give identifications like this and you need to distinguish, especially aldehydes, ketone, you need to distinguish. Right, first one I will put Br2CCl4. What do you put? Br2 in the presence of CCl4. You can remember, if you join the seminar, alkenes and alkynes, or if you had done in class or whatever, if you had done alone or whatever, right, alkenes and alkynes are going to react with Br2 in the presence of CCl4. Okay, in the presence of CCl4. So benzene, you know benzene, right? Benzene doesn't react with Br2, and you know this phenol and aniline is going to react with Br2. So I taught you these things. It's like orthopara director, strong activator. It's going to just react with Br2 without any presence of catalyst. Okay. without any presence of catalyst, Br2 is going to react with what? Phenol, aniline, and alkene and alkyne. Right? Alkene and alkyne. If you know Br2 reacts, what happens? If Br2 reacts, what happens? It's going to form, it's going to decolorize. It's going to decolorize. Right? What it happens? It's going to decolorize. Okay. It's going to decolorize with alkene and alkyne. It's going to decolorize with alkene alkyne, and it's going to form a white precipitate with phenol and aniline. Okay, white precipitate OH Br NH2 Br, you know this. Okay, these are the white precipitates which are going to be produced. These are the white precipitates. Right? These are the white precipitates which are going to be produced. Right? එතකොට compounds මොනවද බලන්න? White precipitate නම් white precipitates නම් මොනවද මේ phenol aniline. Decolorization විතරයි නම් decolorization කියන්නේ මෙයා පාට දුඹුරු පාට වගේ. හරි? It's like brown color, so it's decolorizing, colorless. You know, Br2 will go to Br minus. මුගේ color එකක් නැහැනේ. දන්නවනේ. හරි? It's going to decolorize. හරි? It's going to decolorize. So that's the observation. That's the observation. Right? ඒක තමයි පළවෙනි එක. ඒක තමයි පළවෙනි එක. හරි? Then after that දැන් මෙතන CCl form ඕනේ නැහැ. හරි Br2 විතරක් දැම්මත් මේක reaction එක වෙනවා. CCl4 කියන්නේ ඒක දාන්නේ medium එක. හරි. මේ CCl4 නැතුව reaction එක වෙනවා. The reaction can happen without CCl4. In mechanism, if it like does something in the mechanism, you need to put that. If it doesn't cooperate in the mechanism of that reaction, it doesn't function. It doesn't do anything. Okay, so Br2 is the ultimate thing which you can put. Then මේකට යද්දී CCl4 medium එකේ මේකට යද්දී water medium එකේ ඔහොම එක්කත් තියෙනවා. හරි. You can put this in the water. You can put this with water Br2. Here CCl4. ඒකත් ඕනනම් ලියා ගන්න. You can write that also if you want. Okay. Then after that, this is important. Ammonical silver nitrate කියලා එකක් තියෙනවා. කවුද? මොකක්ද කිව්වේ? ammonical silver nitrate. මොකක්ද? ammonia ඉන්නවා, silver nitrate ඉන්නවා. මේකට කියන්නේ කවුද? ammonical silver nitrate. ඉස්කෝලේ ගියා නම් ප්‍රැක්ටිකල් කරලා තියෙනවා නම් ඕගනික් දන්නවා නම් මේක දන්නව මොකක්ද කියලා. හරි. You know what it is. Ammonical silver nitrate. දැන් මේක මෙතනින් කිව්වම මෙතන ඊළඟ ඉන්නේ ammonical silver nitrate. හරි. It's going to produce a white precipitate. Right? It's going to form a white precipitate with what? Terminal alkynes. Right? Terminal alkynes කියන්නේ මොකක්ද? Terminal alkynes. With terminal alkynes, it's going to produce a white precipitate. It's going to produce a white precipitate with terminal alkynes. Right. Now what? Again, you are going to put ammonical silver nitrate, but this is a different observation, right? This one, ammonical silver nitrate. What? You wrote it in the above, so write it down here also. Ammonical silver nitrate දානවා. ඒත් ලස්සන observation එකක් කරනවා. හරි. This is so beautiful. What do you get? A silver mirror. What do you get? A silver mirror you are going to get. Make a characteristic කියන්නේ very characteristic. මේක aldehyde වලට විතරයි වෙන්නේ. aldehyde වලටයි තව එකක් වෙනවා. formic acid කියලා diet එකක් ඉන්නවා. ඔගෙත් ඒක වෙනවා. හරි. What? Aldehyde and formic acid it's going to happen this reaction. මොනවද aldehyde කියන්නේ? Aldehyde or formic acid. What does formic acid look like? දෙපැත්තෙම හයිඩ්‍රජන් ඉන්නවා කාබන් ඩබල් බොන්ඩ් හරි. මේ formic acid මේ aldehyde. මෙයා formic acid. හරි. මෙයා formic acid මෙයා aldehyde. මේ සිල්ල මිල හැදෙනවා ammonical සිල්ල nitrate. හරි. පට්ට. තව තියෙනවා. ඉවර නෑ. Not finished. Write this down. Write this down. Board day ඉඩ දෙනවා නම් තව කියනවා. So I need you to write this so I can erase. හරි. So why are we having these identifications? බලලා කියන්න බෑනේ. Now if someone gave you alkyne and an aldehyde in two test tubes and ask you to identify them. මොකද කරන්නේ? ගන්නවා silver nitrate දෙකම දානවා. You are going to take silver nitrate and you are going to put into both test tubes and one will form the silver mirror and the other one will form the white precipitate. Inorganic වගේමයි හරි. Inorganic වගේමයි. මේ පොඩි කම්පවුන්ඩ් එකක් තියෙන ammonical silver nitrate ඊට පස්සේ හම්බ වෙනවා D2,2,4-DNP කියලා. හරි. ඊට පස්සේ එච්චරයි. That's all. Right, special compounds. Ammonical silver nitrate 2,4-DNP NaOH දාන්න පුළුවන්. Right. හරි. ඉවරයි. දැන් මේක erase කරනවා. I'm going to erase this. Right? ඊට පස්සේ now what? I'm going to put H plus KMnO4. දැන් දන්නවා මොකක්ද මේ කියලා. හරි? What is this? Strong oxidizing agent. H plus KMnO4. Observation එක decolorization. මෙයාගේ color එක purple color. You learn this in what? Inorganic. හරි? මෙයා decolorize වෙනවා. ඇත්තටම මෙයා alkene එක react කරනවා. Alkyne එක react කරනවා. They will react with alkyne and they will react with aldehyde. They will react with ketone. They will react with ketone and they will react with what else? Alcohol. Okay. Alcohol නිකන් alcohol නෙමෙයි, primary and secondary alcohol. Tertiary alcohol එක react කරන්නේ react කරනවා. Yes, it reacts. No, it doesn't react. It doesn't react with tertiary alcohols. Then what else? Alkene, alkyne, aldehyde, ketone, benzene also it reacts. Benzene එක අර explosive reaction එක වෙන්නේ. හරි ඒක දාන්න නැතුව වෙනවා. Let's not put that. Sorry මෙතන මේ if you were there in the when I was discussing this formic acid, this is OH. I forgot. Formic acid is OH and this the aldehyde part is this one. Formic acid is this one. Mistake. Formic acid is this. Okay. Right. Thank you for telling. Right. Then primary and secondary alcohol and formic acid is coming here also. Formic acid. Hurry. Compounds which undergo H plus KMnO4 reaction, which means it can oxidize, right? It can oxidize. Hurry. ඊට පස්සේ මේක erase කරනවා. I'm going to erase this. I'm going to erase this. Right. Now what? Now 2, 4, D and P. Sometimes your parents call you at home with another name and they call you in school with another name, right? So likewise you are having nicknames. Some people Sudu Buta, whatever. Know it. Right? So this, what is this? 2,4-dinitrophenol. Dinitrophenyl hydrazine, the real name of it. Dinitrophenyl hydrazine, you call this the Brady's reagent. What? The Brady's, the nickname. The Brady's reagent. Right? What do you call them? The Brady's reagent. It's like the like the, what do you call? The one who just nickname can even nickname. And Brady's reagent. So what does it give? The observation. The observation is a precipitate. Yellow orange precipitate. Yellow orange precipitate. Yellow orange precipitate is going to be formed. Then it can be an aldehyde. It can be an aldehyde or a ketone. Aldehyde or ketone. Aldehyde or ketone can be formed. That's the compound forming. Okay, the observation is yellow color, yellow orange precipitate, and 2,4-DNP. Now this is a characteristic observation for aldehyde ketone. Formic acid දෙන්න formic acid ඇවිල්ලා මේ reaction එකට disturb කරන්නේ නැහැ because this is a characteristic reaction for aldehyde ketone. Isomerism questions වල මේක දීලා දෙනවා. හරි. Many places they have given. Even ammonical silanitrate, silver, I think they will give. Okay, these three are they are mostly questioned. Okay. Then after that 2,4-DNP කතාව හරි. 2,4-DNP done. Then what? Then when you put sodium hydroxide, if it gives a largely exothermic reaction, largely exothermic reaction it's going to liberate the most amount of heat. It's going to liberate the most amount of heat. So it's going to be acid halide. What is acid halide? C double bond oxygen chlorine and you have CH3. May chlorine OH can replace what I said you in the note. It is very highly exothermic and it's going to be the observation. So that's the observation for acid halide sodium hydroxide reaction. Then after that ammonical cupric chloride. Cuprous chloride. Cuprous the cupric the one. CuCl. Ammonia and CuCl. So what do you get here? You're going to get a Briggs red precipitate. Briggs red precipitate. Make a famous man. This is not famous. Okay. This is not famous. CH3 C triple bond C Na. Right? Na. Alkyne. This is the only compound which gives a Briggs red precipitate with this compound. Okay, so what happens is copper is going to replace this carbon. Then make a bio bio fading reagent. This what you have the Benedict's test, right? In Benedict's test, this copper is coming and giving a Briggs red precipitate, right? So here it's the Briggs red precipitate, and it's easy to remember. This copper thing is there in biology also. The copper thing is there. Right? When the copper thing is there, you're going to get the Briggs red precipitate. Right. Briggs red dye going on. Where do we get Briggs red? We are going to get Briggs red color in the flame test of calcium. We know that. Okay. And high organic color where the calcium thing. It's like a separate point. Right? Okay. So HRI deep points HRI. I mean that's everything for the deep points. Deep points means the things which are questioned in the exam. This one. Write this down. Write this down. Write this down. Then after that, I have a test for what you call the primary, secondary, and tertiary amines. A test for primary, secondary, and tertiary. But acid halides, alkyl halide, sorry, acid halide coil right. මොකක්ද reaction එක? What is the reaction? Primary, secondary and tertiary alcohols. Sorry. Hi. Then I'm going to erase this. Hari, දැන් ඕක ලියුවේ නැත්තම් rewind කරලා බලන්න. Hari. Rewind කරලා බලන්න. Then identification of primary, secondary and tertiary alcohols. තමයි mistakes and mistakes. Right? Identifications of primary, secondary and tertiary alcohols. Hari, identification of primary, secondary and tertiary alcohols. මේක ලියන්න topic එකේ. Hari. Topic. Identification of primary, secondary and tertiary alcohols. Hari. Then okay. Then අපි ගන්නවා tertiary alcohol එකක්. tertiary alcohol එකක්. R groups තුනක් තියෙනවා. mu tertiary. හරි. Then there is another one with 2 R groups and hydrogen. Then there's another one with 1 R group and 2 hydrogens. OH. හරි. මොකක්ද දාන්න reagent එක? reagent එක අපි කියනවා Lucas reagent. අපි මේකට කියනවා Lucas reagent එක කියලා. මොකද්ද? Anhydrous zinc fluoride conc HCl. What? Anhydrous zinc fluoride conc HCl. Anhydrous zinc fluoride conc HCl. එතන anhydrous zinc fluoride conc HCl. මේකට කියනවා Lucas reagent. හරි. මොනවද? Lucas reagent. Lucas reagent. හරි. Lucas reagent. මොකද වෙන්නේ? This tertiary alcohols දැන් දන්නවා මේක form වෙන්නේ මොනවද? Lucas reagent එකත් එක්ක form වෙන්නේ chloride. This OH is going to be replaced by chlorine. අපි ගමකද? That halogen supplies like halogen supplies is going to replace this OH with a chlorine. So this reaction is going to produce an instant turbidity. හරි? මොකද්ද reaction එකේ observation එක? Instant turbidity. හරි? මේක තමයි observation එක. This is the observation. But instant turbidity. Then this one are see මේක color කරනවා. Instant turbidity, that's the observation. That is the observation. Then next one R. So 2 R groups, then hydrogen, this chlorine. This is a slow turbidity. Slow turbidity. Slow turbidity. It takes like slow turbidity. It takes like 2 minutes, 5 minutes, 5 to 10 minutes. Reaction you should do this in school. Should do this in school. If you don't have school, just go with the YouTube and see at the practical. Then this one CH2R, which means this is a primary one. This is very slow reaction. What? reaction. Very slow reaction. Very slow. What's the very slow reaction? Very slow reaction. The identification. දාපු ගමන් instant turbidity එනවා නම් it's a tertiary alcohol. Make up the isomerism question. Isomerism question, they will give this. Okay, this observation thing, Lucas reagent with Lucas reagent, instant turbidity, slow turbidity, and very slow turbidity. Very slow in those like weeks or days it will go. Then the compound, anhydrous zinc chloride, ConHCl, or Lucas reagent. That's the nickname given. Like this, you found what else? Brady's reagent nickname. Then likewise, you saw different type of reagents nicknames. You write this, I will tell when I remember. You write this. Last catalyst, I forgot the name. Like sometimes, like you know it very well and you forget it. Things like that happen in at exam, at the class, right? Write this. The Lindlar's catalyst was hydrogen. You have palladium, quinoline, barium sulfate. We did it in the seminar. Right. Like this. Then after that, what did we finish? Identifications. Done. Acidity variation done. Basicity variation done. Then after that, ultra power short knots done. What else did we do? That's all, right? What do we have to do? Boiling point variation is there, right? Boiling point variation next I will do. Okay. Right, now boiling point variation. Right. This is the one you need to know, boiling point variation. Right. Now, boiling point variation of organic compounds, right? It's boiling point variation of organic compounds. Or boiling point variation of organic compounds. Then make a you should need to keep this in your mind. Okay. This is the variation. I'll give you the variation first. First hydrocarbon. Hydrocarbon is going to be the last one. Okay, least. Then RCl. What is this? Alkyl halide. Okay. Then after that you are going to have aldehyde ketone. RC double bond oxygen, hydrogen O CH3. Hydrogen O R group. Okay. Hydrogen O R group. Hydrogen O R group. Right. Then you are going to have amine. But RNH2. RNH2. After that, you are going to have ROH and RC double bond OH. ROH, RC double bond oxygen OH. Right? This is the variation, the boiling point variation. This is how it goes. Okay, this is how it goes. Right. Now, what makes them differ? Now, this is make bonding. This is bonding. Bonding lesson you learn the intermolecular forces. Now, I told you intramolecular and intermolecular. There are two types. Okay. I need to inform me the group. Wait. They can rewind and watch it. Right. Then, what makes them differ is the intermolecular forces. Then, think like, okay, if between you and your friends are greater, if the bond between you and your friends are greater, what happens is they don't like to separate. That's it. Now, what do you mean by boiling? Boiling means you have some liquid, let's say, you have some liquid, liquids are vaporizing. What do you mean by vaporizing? Their bonds are broken and they move as individual particles. That is the variation actually. That is how it goes. Okay? That is how it goes. Right. So breaking bonds. Breaking bonds. If the bonds are weaker, then it is easy to break. It is the how the bonds are forming with each other. Then water got the water with a boiling point 100 degrees Celsius, right? Like when you heat it to 100, the bonds are broken and it will evaporize. So that's going to happen. So here also this hydrocarbons. What do you mean by hydrocarbons? Alkane, alkene, alkyne. Okay, alkane, alkene, alkyne. මොනවද තියෙන්නේ? London forces. හරි වෙන මොනවද තියෙන්නේ? එච්චරයි. හරි London forces. London forces dominate. Man dominating ඒවා star එකක් දානවා. හරි. The forces which are dominating, I put a star. Then here what you have? You have London forces, of course. I'll put London forces LDF. LDF. London forces are LDF. LDF. Then next one it's going to have dipole. You know it. You should know this bonding lesson knowledge. But you have dipole. This is weak. This is not much strong. Dipole. Weak dipole. Another weak dipole. This is very weak. This is very weak. Then next one you are going to have aldehyde ketone. Dominating one of the London forces. Dipole thick weak, very weak. Not much strong. The dominating London forces, so star. Dominating star. Then here RC dipole. So the boiling point is more than the hydrocarbons. It was RC double bond H again aldehydes. LDF. Dipole. Hydrogen bonds. Dipole make a dominating. Dipole dominating, and obviously their boiling points are higher than the what do you call it? Alkyl halides and hydrocarbons. Dominating dipole. Methanol. LDF. Of course there is LDF. There is LDF and there is hydrogen bonds. But you have hydrogen bonds. And the dominating one is the hydrogen bonds. I'll tell you exactly how does the hydrogen bond is forming. I'll tell you exactly how the hydrogen bond is forming. LDF is there. In addition, there is hydrogen bonds. Hydrogen bonds. Then after that, here you have LDF, of course. The dominating one, hydrogen bonds dominating. Here, LDF. You have hydrogen bonds, H bonds. And then you have dipole. How do you get dipole? May oxygen is it? Oxygen is a double bond oxygen, right? So it is like creating a dipole. Then තුනක් තියෙනවා. හරි ඒකනේ මු වැඩි ඉතින් පේනවනේ වැඩි කියලා. හරි there are three. There is OH group which donates electrons and form hydrogen bonds, and there is C double bond oxygen which will form dipole forces. Dipole forces. Right? එතකොට පේනවනේ දැන් මෙතන dominating කට්ටියට hydrogen bonds ඊට අමතරව dipole ඉන්නවා. මෙතන hydrogen bonds dipole LDF. හරි. This is the basic variation. හරි. Basic variation. I will go into one by one and I will explain you how to distinguish. Hurry, how to distinguish. Hurry, now write the topic hydrogen bond formation. Hydrogen bond formation. Hydrogen bond formation. For hydrogen bonds to be formed, there should be two requirements to be fulfilled. Then to become the prefect of a school, you need to have some certain requirements. So here also to form hydrogen bonds, there should be certain requirements. Right? It's okay. You go and eat and come, you can rewind and watch it. Then I can finish this quickly. Then hydrogen bond formation, you need to have two things. Okay, you need to have two things. What are they? First one, there should be a fluorine, oxygen or nitrogen atom bonded to hydrogen. What they do? There should be a fluorine atom bonded to hydrogen, oxygen atom bonded to hydrogen, and nitrogen atom bonded to hydrogen. From one of these three, there should be one. Right? Fluorine, oxygen, nitrogen bonded to hydrogen. Then the next requirement is should have a lone pair. Right? The fluorine, oxygen, nitrogen should have a lone pair. Should have a lone pair. There should be oxygen, fluorine or nitrogen atom bonded to hydrogen. අනිත් එක තව මොලිකියුල් එකක් තියෙන්න ඕනේ ඒකේ lone pair තියෙනවා oxygen එක. හරි. There should be a lone pair. So then only hydrogen bond will form. These are the two requirements to have to form a hydrogen bond. These are the two requirements to have to make a hydrogen bond. These are the two requirements. Right. Then I'm going to write few examples. Okay, I'm going to write few examples and let's see if they form hydrogen bonds or not. Example number 1, water. Water molecules, they are two water molecules. Okay, two water molecules. Here one water molecule. Here is the other water molecule. Hydrogen. Now what? Then make a first. The second first point second point. Make a first point second point. This is very easy. Listen, okay? Listen, it's very easy. Recording bell it's very easy. Point number 1, point number 2. Point number 1 is having an fluorine, oxygen or nitrogen atom. Then other one should have a lone pair. Okay? Oxygen bonded to hydrogen. It have to. So this point is there. So second one, it should have a lone pair. Many lone pairs. So this one there. So here also both are there. Now the hydrogen bonds are formed with first point and the second point of the other one. First point and the second point. Hydrogen bonds. There are two hydrogen bonds here. One to two and one to two. That's the example number 1, water. Then next one, I am taking example number 2, nitrogen plus hydrogen. This is NH4 plus. Here I say there is water, oxygen, hydrogen. There is a double bond lone pair. Make a first point the nitrogen atom, oxygen atom, fluorine atom attached to hydrogen. Good. Make a lone pair? No. It doesn't have a lone pair. Now what? Hydrogen bond formula. Let's see. Let's see. Now here, first point, obviously there are oxygen atom attached to nitrogen. Lone pairs? Yes. Then hydrogen bonds are formed with the first point of the first one and the second point of the second one. ඒ කියන්නේ මෙතන form වෙනවා. එතකොට මේක hydrogen bond form වෙනවද? ඔව්. It forms hydrogen bonds. මෙතන hydrogen bond form වෙනවද? ඔව්. It forms. හරි? Example 1, example 2, then I will write the example 3. I should erase this now. Write this, write this down. Just pause the video and write it. Pause the video and write it. මේක recording එක වෙනවනේ හිටින්. මේක ඉඳ video එක. හරි? Write this down. Then example number 3. Example number 3. Example number 3. What do you have? I'm going to put ketone and a ketone. CH3, C double bond oxygen, CH3, CH3, C double bond oxygen, CH3. Right? Point number 1. Oxygen, fluorine, nitrogen atom bonded to hydrogen. The oxygen atom is not bonded to hydrogen, not there. Second point, it should have a lone pair. Lone pairs lone pairs lone pairs but it cannot form any bonds. Let's see the other one. Maybe lone pairs lone pairs make a first point oxygen atom, nitrogen atom, fluorine atom attached to hydrogen. Second figure මෙහෙම form වෙන්නේ නැහැ bonds. මෙහෙම form වෙන්නේ නැහැ. Bonds form වෙන්නේ the first point of the first one and second point. Make a wrong, make a correct. Bad. Make a wrong, make a correct. That. So no hydrogen bond formation. No hydrogen bond formation. Write it down. This is a lot of people don't know this. Hydrogen bond formation. They don't know how does it work or how they just know that OH and H is forming a bond and it is hydrogen bond, but they don't know the real theory behind this. Okay, write this down. Right. Now I'm going to erase this. Right. Now I'm going to erase this. Now you know what happens when hydrogen bonds are forming. Hydrogen bond strength, right? Hydrogen bond strength you can find now. Okay. Next is what if there are two compounds? What if there are two compounds? CH3, CH2OH. CH3, CH2OH. And there's another compound CH3, CH2, CH2, CH2OH. Let's take another one. Hydrocarbon. Let's take hydrocarbon. What if they have the same type of forces? You have to compare two compounds with same type of forces, but they are like this: CH3, CH2, CH3, CH2, CH2, CH3. It's like a linear one. It's like a linear one. Then here you have CH3, CH3. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Hurry. Right. So you can see here if the type of forces becomes equal, there should be two priorities you should go after that. Okay, what are the two priorities? Number one, you should check for the molar mass. Okay, molar mass. You should check for the molar mass. If molar masses are different, then okay, you can choose. The one with the higher molar mass, I'll write here high molar mass, high boiling point. High molar mass, high boiling point. So that's it. Then number 2, surface area. Right? Number 2 is surface area. So surface area is the next one you should look at for. So why do you look at the surface area and molar mass? London forces depends on these two. Right? London forces depends on these two. Right? So when surface area increase, right? When surface area increase, LDF increase, boiling point increase. This is BP and BP. I think boiling point is going to increase. Boiling point is going to increase. Right? Surface area වැඩි boiling point increase වෙනවා. දැන් මේක Montessori ළමයින්ගෙන් අහන ප්‍රශ්නයක්. So this is a question asked from Montessori or very small grade 1, grade 2 question. Okay. So this compound is the linear one. Now which one has the highest surface area? This one or this one? Alright. Then make a, this is best way to do this is you just take this compound and just look. Okay, which one has the highest surface area? Then මෙහෙම ගියාම මේක වටයක් යන්න ඕනේ. මේක සංගාලි වෙන්න ඕනේ. So which one has the highest surface area? The linear ones are going to have the higher surface area. Before that you should check for the molar mass. Molar mass බලන්න. How many carbons? 1 2 3 4 5. 1 2 3 4 5. 5 carbons. Hydrogen 1 2 3 4 5 6 7 8 9 10 11 12. 1 2 3 4 5 6 7 8 9 10 11 12. Then molar mass equal. So you should look into the surface area. Now which one has the higher surface area? This one has the higher surface area than this one. So which one has the higher boiling point? This one. Hari? If the forces become equal, then you look into molar mass and surface area. Hari? That's it. That is it. මේ තුන special. Hydrogen bonds alone. They are forming hydrogen bonds, so they are greater. Hari? Other than hydrogen bonds, they are forming LDF forces. Hari? LDF forces. Right. Now, oxygen and hydrogen LDF forces are strong. Sorry, oxygen hydrogen bonds are stronger than nitrogen. That's why alcohol is greater than amines. That's it then. Then everything is done, I guess. Right? So we keep a full stop to this organic seminar series and then we are done. So we decided to do the last seminar free for all. So here we go. Done and dusted. Right? Done and dusted. Okay. Right? Now next we are going to look into inorganic. So I'll inform in the group. After a while I'll just do this stuff and tell you, okay? Regarding inorganic and what we are going to do. Okay, so for now that's all. I'm going to end the meeting now and thank you for joining. For everyone who joined and stayed, thank you. Right? Okay then. See you in the inorganic seminar. Now I'll finish the meeting.